Hello, Elder students, Mr. Lawrence here once again, and in this video we're going to be translating and solving compound inequalities using and or or. And you might be thinking, Mr. Lawrence, what is a compound inequality? Well, it's just going to be two inequalities joined together by the word and or. And the number line graphs are going to be pretty cool because they're going to end up usually looking something like this on the same number line, okay? Or they might look something like this on the same number line. Of course, they could be those with, the points colored in, and I'll bet that Aiden can tell me when the points are colored in. What's that, Aiden? Yes, right, if we say equal to, right? All right, very good. And of course, an and like this could also be colored in. You might not know what I mean by an and like that, but I'm going to get to that soon. Almost looks like the buttons down the marching band jacket or something like that. Anyway, let's get down to the problems. All right. Number one says 3 less than twice the number. Well, let's just stop right there. We know 3 less is minus 3, right? Twice the number. If the number is n, twice that number would be n. So we need 3 less than 2n. So I'm going to do 2n and 3 less than that. Okay, is less than 17. Well, that's pretty easy. Okay, and, ooh, very important, and greater than 12. Do I just go like this? No, that would be terrible. What I need to do is rewrite the 3 less than twice the number. And that's greater than 12. There we go. That looks better. Now, by the way, with ands, if I wanted to, you see how 12 is going to be less than 17? If I wanted to, I could rewrite this a little bit differently. I'm going to go ahead and just move this over, and I'm going to solve this just like you think I should, but then I'm going to go ahead and show you another way to do it. So all I have here are 2 inequalities, and I'm going to solve them one at a time. I'm not going to bounce back and forth between them because I'm afraid of making some kind of silly error. Okay, let's do that. And we're going to get 2n, which is less than 20. And then we'll divide by 2. The inequality will not flip. What's that, Madison? You said the inequality won't flip because we didn't divide by a negative. Right, very good, Madison. All right, so we're going to get n is less than 10. And now I come over here and I'm going to add 3 to both sides, just like I did before. I should get rid of that underlined 12 there. Oops, I can't. Let me Control Z. Will Control Z send this back? Oh, it will. How lucky am I? All right, let me get rid of that underline there because I don't want you to think that's division by mistake. Uh-oh. Danger, Will Robinson. Apparently. All right, here's what we're going to do. We're going to erase this. There must be a gremlin in my system. Okay. All right, I'm done with that. I'm just going to rewrite it. I'm going to show the work. Okay, I'll rewrite it over here. 2n minus 3 is greater than 12. I'm going to add 3 to each side. All right, there we go. I'm going to get 2n is greater than 15. And I'm going to divide by 2. Yeah, and Mr. Suklaw's saying, you know what, that inequality is not going to flip, Mr. Lawrence. And I'm going to get 7.5. So I have this compound inequality. Now, I'm going to graph it on a number line, right? I'm going to graph it on a number line. So let me get a number line out here. Yeah. And I'm going to show only 2 numbers on this number line. I know I'm in the habit of showing 3. But in this one, I'm only going to show 2. And if you want to show 4, you can go ahead. I'll bet you know the 2 I'm going to show. First of all, I'm going to show the number 10. Okay? And I'm going to show the number 7.5. Okay. Now, if you want to show a number over here, like say 5, you can, and then maybe I'll show 12 over here. All right. Now, I'm going to put an open point at 7.5 because there's no equal signs, and an open point at 10. Now, an AND statement, I hope you know what an AND statement means. Let's say that after school one day, I was going to treat Megan and Nick to some ice cream, okay? If I only buy Megan the ice cream, is Nick going to be upset at me? Sure he is, because I said I was going to buy ice cream for Megan and Nick. If I only buy ice cream for Nick, is Megan going to be upset? Sure, because I said I was going to do it first. And is inclusive. It means both must be true at the same time. So what I need on my number line are the numbers that are less than 10 and greater than 7.5. Well, those numbers would lie in between the two, right? They would lie in between the two from here to here. If I pick any number in that region, that shaded region, and I plug it into the original inequalities, I will get a true answer. Let's use 9. Let's plug 9 in. Okay, so I'm going to test it here. Hold on, let me erase some of this stuff. Hopefully it doesn't erase the whole problem like it did before. I'm not sure what was going on there, but it seemed to work that time. Okay, so I'm going to take 2, and in parentheses I'm going to put 9, because 9 is in between the middle. And then I'm going to do minus 3 is less than 17. I'm going to see if that's true. Well, 2 times 9 is 18, minus 3 is 15. Is 15 less than 17? You bet your boots. So it checks that way. Now, it's an and, so I have to be careful. I have to get, make sure it satisfies the other inequality. So I'm going to take 2 and I'm going to stick the 9 in this inequality. Less than 3 is greater than 12. Oh, and 12, 18. Did I say less than 12? I hope I said greater than 12 there. Plus 3 will be 21. Is 21 greater than 12? It sure is. So you see, any number in this region is going to satisfy both. If I pick a number outside the shaded region, like let's say I plug 0 in, that's definitely outside the shaded region, it's only going to satisfy one of the inequalities. And that's a problem. Did you catch that, Mackenzie? Because it's an and, so it's Megan and Nick getting ice cream. So both have to end up being true. Watch, if I plug 0 in, I'm going to get 2 times 0 minus 3 is less than 17. Hold on 1 second here. Sorry about that. We're doing some laundry in the basement, and it sounded like water was emptying onto the floor, but it just sounded that way, fortunately. Sorry for the interruption. So let's see here. I'm going to get 2 times 0 is 0. 0 minus 3 is negative 3, and that is less than 17, so it checks. But watch what happens when I stick it into the other inequality. I'm going to get 2 times 0 minus 3 is greater than 12. When I simplify this part, I'm going to get negative 3. And negative 3 is not greater than 12. So you see, that's a false statement. That won't work. I need only the numbers that give me a true statement for both parts of the inequality. Why? Because it's an and. Have I said that enough? Now, you see how this and looks? Do me a favor. Hold your hands out in front of you and make fists, and then stick your thumbs towards each other and actually touch your thumbs together. Ands will typically look like that, okay? And I can show you that in class if you don't understand what I mean. It's hard to visualize. What I'm saying is these here are my fists, and this is my thumbs touching. Ands will look like that in every situation except for one special not a counterexample, but one special exception. But we're not going to talk about that. Okay, now I promised to show you a different way to do an and. It's the way I like to do them, but most students like to do them that first way. Since the 12 is going to be less than 17, I can write the and like this. I like to do it this way, but again, you do it the way you want. I've got this 12, And the 12 has to be smaller, right? Less than. Okay, you're saying, why did you flip the inequality? Well, technically I didn't, because 2n minus 3 is greater than 12. That means the same thing as 12 is less than 2n minus 3. And then what I'm going to do is I'm going to rewrite this, less than 17. Now, again, you don't have to do it this way. I like to do it this way because I'm going to solve this inequality all in one shot. Normally, I would add 3 here, wouldn't I? Well, I have to add 3 in all 3 places. And when I do that, I'm going to get 15 is less than 2n, which is less than 20. And then I would divide by 2, right? But I would have to do it here and here. So this is going to turn into 7.5 is less than n is less than 10. I think I like this way so much better because it looks like this picture to me, where these are the endpoints, and then all the numbers in between are the solution. Okay? But again, there's nothing wrong with doing it this way. Just remember that ands will look like that. All right, let's go down to number 2. And it says 1 less, wow, that's minus 1, then 5 times a number. Well, that would be 5n, wouldn't it? So let me write 5n minus 1 is either greater than or equal to 10, greater than or equal to 10, or, do you see that or there? It is less than, well, I need this again, 5n minus 1 is less than or equal to 2. Just like the last problem, I'm going to solve each part. Plus 1 to both sides, 5n, going to be greater than or equal to 11. Going to divide by 5, going to divide by 5, and it's going to be greater than or equal to 2 1/5. Or, add 1 to each side. I'm going to get 5n is less than or equal to 3. I'm going to divide by 5 and divide by 5, and I'll get n is less than or equal to 3/5. Okay, a little bit more than halfway. And this is an or. Now let's go back to taking Megan or Nick out for ice cream. If I'm going to take Megan or Nick, only one of them is going to go. With this inequality, with my number line, only one part has to be true at a time. So I'm going to draw this number line. Let me get an endpoint, an arrowhead on the starting endpoint. Okay. I'm going to show on my number line these two numbers, 2 1/5 and 3/5. Okay, so there's 3/5 right there, and maybe that's 1, and then 2 1/5 might be over here. Okay, now they say equal to, don't they? N is greater than or equal to 2 1/5. So I will have a closed point right there. All right, n is less than or equal to 3/5. That'll be a closed point there. Now, if you want, you can have some other numbers on here. You know, you could put 0 on, and you could put, say, 3 on, and then this is going to be 1, I said. All right, now, I need numbers that are greater than 2/5. Well, blank is greater than or equal to 2 1/5. I said 2/5, sorry, 2 1/5. Well, 3 is, so I'm going to shade towards the 3. Well, I'll use my crayons. So I'm going to shade this way. See that? Oh, there we go. How pretty. But over here, it says that blank is less than or equal to 3/5. Well, 0 is less than or equal to 3/5. Remember, you don't want to pick the endpoint when you do that. So I'm going to shade toward the 0. Oh, that's not my crayon. Where's my crayon? There's my crayon. So I'm going to shade that way, putting an arrowhead. So you see the or looks a little bit different than the and. It's still got the 2 endpoints, but this time you're pointing away. Hey, hold your fists out in front of you. Stick your thumbs next to each other. That's an and, correct? Now, just turn your fists over so that the backs of your hands are pointing down and your palms are pointing up with your fists made. That's an or. Your thumbs are pointing to the outsides. Okay, your thumbs are pointing inside, it's an and. Outside, it's an or. That is how almost all ors will look. There is that one special case, but we're not going to talk about it in this video. By the way, you know how I wrote the last problem as one big inequality? Right here, right? That one right there. You cannot do that with an or. You can't do it with an or. Do not write an or as one sentence. All right, let's get on to the third problem. 6 is less than 2 more than a number quadrupled. Well, 2 more would be plus 2. A number quadrupled would be 4 times the number. Quadrupled, you got doubled, tripled, quadrupled, quintupled. Okay, 2, 3, 4, 5. So we have 4n plus 2, which is less than 20. Oh, there we go. We've got 6 is less than 2 more than a number quadrupled, which is less than 20. There you go. Let's see if we can find the range of numbers. So this is going to be an and, isn't it? It's going to be an and, even though the word and didn't appear in the sentence. Well, I'm going to subtract 2, subtract 2, subtract 2, and I'll get 4 is less than 4n, which is less than 18. I'll divide by 4. Inequalities won't flip. Hey, if I was dividing by a negative, which inequality would flip? What's that, Sean? Hopefully you're saying both of them, right? Okay, so the 4 divided by 4 will be 1 is less than n. Those cancel. Those do cancel, but to 1, right? 4 divided by 4 is 1. And then half of 18, I think, is 4.5, right? 4.5. So cut in half, get 9. Cut that in half, get 4.5. All right, so my number line is going to look like this. And let me see here. All right, and I'm going to show 1. I'm going to show 4.5. They're not equal to, so there'll be open points. And if I'm not sure, I could test it. I know how ands look, but if you're not sure, leave that and a blank. And I need a number that 1 is less than, but that number also has to be less than 4.5. So for example, I couldn't put 10 in here. 1 is less than 10, but 10 is not less than 4.5. I need one that's true for both parts of the inequality. So maybe I'll pick 2. 1 is less than 2, 2 is less than 4.5, and 2 might be about there. And so I'm going to shade the numbers in between. I'm like in this crayon feature here. So I'm going to shade the numbers in between like that. And there you go. All right, here comes your video quiz. It's only 2 questions, really. Usually, what do the number line graphs look like for compound inequalities using and then compound inequalities using or? All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.